greater than or equal to 20. It doesn't matter for a continuous distribution. This is the same with the probability for x greater than 20. Not for a discrete. For a discrete distribution is totally different, right? So they're not the same. They're not equal. So if this is 20, what I'm really interested in is determining this area. All this area is the probability that x is greater than or equal to 20. How do I determine this area? It's a rectangle. Base, which is 10, times height, which is 1 over 30. So this is nothing else but base times height. What is the base? Between 20 and 30, so it's 10. What is the height? 1 over 30. So simplify and we get 1/3. And that is the probability that the person is going to be late at least 20 minutes.
Okay, thank you.
Is this okay?
Yes.
Perfect. Okay, so now in problem 1, so we completed this one. So in problem 1, the points x equals and x equals are the inflection points on the normal curve. So it's important to remember that the normal curve, we teach this in calculus, the function opens up and then all of a sudden opens down. This is called an inflection point. IP, inflection point. And the same here, symmetric, where from opening down, all of a sudden it opens up. For the normal curve, these are at x bar plus or minus 1. You don't have to write the 1, I'm just making a point. Since I use here x, I have to use, of course, s. In general, it's mu plus or minus 1 standard deviation. That's what I meant to write. So x bar plus or minus 1 sample standard deviation, s. Better in population terms. Population mean, population standard deviation. Okay. Since I'm just going to browse through and then we'll come back next time and look at others. Yes. Because I don't know how many are they. I don't think we can finish them. What are they? We have 34 questions. There is no way we can finish all 34. And no, your final exam will not have 34 questions. Of course not. Okay, let's look at problem 5. Is everyone with me? Problem 5?
Yeah.
Okay. Who would like to get it started?
Like, read it.
Sure. I'll help with anything. Don't worry about it.
The mean incubation time for a type of fertilized egg kept at 100.4 degrees Fahrenheit is 23 days.
So we have to stop for a moment and take notes, right? So this is problem 5. So the mean incubation time for whatever, mu equals 23 days. Perfect. Let's go on.
Suppose that the incubation times are approximately normally distributed with a standard deviation of 1 day.
Stop. Excellent.
What is the probability that a randomly selected fertilized egg hatches in less than 22 days?
That's it. So what is very important, it says they are approximately normal. So we're talking about x, approximately normal, with mean 23 and standard deviation 1. Okay, so the first question, in less than 22 days. So part A, probability x less than 22 days. Anyone can give us an idea on how to complete this? Anyone else? Just an idea. It's okay if you're wrong. We're reviewing now.
Use the standard normal curve.
Good. So this is normal CDF, cumulative density function, from negative infinity to 22, comma, 23, comma, 1. Okay, negative infinity already appears there. Upper, 22. Mean, 23. Standard deviation happens to be 1. Fine. So the probability is, let me go back to page 3 now. So that is 0.1587 or 15.87%. Okay, next question. Part B. Anyone would like to look at part B? Do we remember how to do this, or do we want to look at any other? B, C, or D?
I have a question.
Yes?
Can you review how to do this in StatCrunch?
Yes. Absolutely.
Thank you.
Professor, I think you're muted.
Am I?
Yeah, we couldn't hear anything.
Oh, I wasn't saying anything. I was looking. Oh, I didn't share my screen?
Oh, never mind. I thought you were talking. I'm sorry.
No, I wasn't saying anything. I was just going through all these steps for the normal. And we don't want in between. We want standard. So the mean is 23. No, the mean is 22, was it? Where is my page? I put it away. The mean was 23, yes. And the standard deviation is 1. And we want less than, yes, we do want less than. And we want 22. And compute. And we have to get the exact same number. What did we get with 15.87? 0.1586, 0.1587. Is this okay?
That's good. Thank you.
Thank you. Okay, where am I? Do we want to look at B, C, or D? Or we move on to the next problem?
Actually, can you do? Wait, maybe part C.
C is in cat?
Yes.
Okay, between 21 and 23. Very good. So that's the probability between 21 and 23. Remember, because it's continuous distribution, it doesn't matter if I put equal symbol or not. Okay, so the same thing. Since I have StatCrunch up, why not? I want in between now, and I want on this side. On this side, I want.
Oh, you would just use that function.
I'm sorry.
You would just use the between function. Okay, that makes more sense. I just forgot how to do it on StatCrunch.
That's okay. No worries. So between 21 and 23, and I compute, and that is 0.4772 or 47.72%.
Okay, thank you.
Thank you. Do we have anything else that we want to look at in problem 5? If not, I'll consider it completed. Any other part? Would it be unusual for an egg to hatch in less than 21.5 days? Okay, let's take a look. (21.5). Okay. So we have for less than 21.5, x less than 21.5, I got 0.0668, which is greater than 5%. And because it's greater than 5%, I will say not unusual. It is not unusual. Okay, so where am I? Page 2, page 3. So we looked at these. Okay, moving on. Okay. Complete the sentence, call the standard deviation. Okay. Then a sample of obtained from a population, describe the sampling distribution. Okay, yes. Good. Problem 8. So let's take a look at problem 8. Who would like to get us started with 8? Anyone? Like Evan? I haven't heard. Evan, are you with us? Alex, are you with us? Evan, Alex? Okay, they're not with us. Anyone else would like to give it a shot to get problem 8 started?
I can start it.
Thank you.
Wait, I can't see it.
Oh, I thought you opened it on, you can open it, right? On a different screen.
I can, if you don't have it open.
Yeah, you can go. It's just hard for me to have both open. So you can go, Emily.
Okay.
Suppose a simple random sample of size n equals 49 is obtained from a population with mu 90 and standard deviation.
Excellent. So
sorry,
remember
sigma
what we
of
do.
21.
Remember what we do. Right away, we write 49, and we write mu equals 90, and sigma equals 21. It's a simple random sample. We don't know if it's normal or not, but the size is over 30. Describe the sampling distribution of x bar. Remember what we do immediately. X bar is definitely normal with mean, the same mean, but the standard deviation is sigma over the square root of 49. Yes, 49, the square root of 49 is 7, 21 divided by 7 is 3, so I can write this. And this is the sampling distribution of x bar. And that answers part A. Now they want what is the probability for x bar to be greater than 94.5. Okay, in part A, x bar greater than 94.5. And I use normal CDF from 94.5 to infinity, mean standard deviation. Stop me if you have any questions anytime for any reason, right? This is very important. So normal CDF from 94.5 to infinity. And the mean now is 90, and the standard deviation is 3. So the probability is 0.0668. On the next question, what is the probability that x bar is less than? And what is the probability that, careful, this is x. Very different, right? So in part B, they want x bar to be less than or equal to, it doesn't matter, it's a continuous distribution. And in part C, find the probability that x, not x bar, is between 86.85 and 95.1. So let me put this away. So this uses the same mean and standard deviation 90 and 3, but this does not, right? So this is x bar. So I have to use the mean of 90 and the standard deviation of 21. So where's my mouse? Okay, I put my papers over my mouse so I couldn't find it. Okay, so here it is. So with normal CDF this time, we want less than or equal to 83, so the lower is negative infinity. And the upper is 83.85. And the mean is 90, but the standard deviation is not 3, but it's, oh, yes, I'm still talking about x bar. So this is 0.02018. But now I repeat, normal CDF, the lower this time is 86.85. The upper is 95.1. But careful, because the mean is the same, but the standard deviation is 21, depending on what we're asked. So this is 0.155559. So careful what you're asked. If you're asked to find x bar greater than, x bar less than, or equal to, it doesn't matter. Or if you're asked x between these two. So that's very important to pay attention.